What's going on, Algebra 2? It's Mr. Brayman back again. Let's go and take a look at Quad 8 today. But to look at Quad 8, which is solving linear quadratic systems, what we're actually going to start with is something back from Algebra 1, solving linear systems. So let's go back and take a look at this. What does linear systems, what does solving linear systems mean? Well, what we're trying to find is how lines interact if they interact. How lines interact if they interact. And I'll kind of tell you what that means here. If they interact. All right. In other words, what we're trying to do is let's go with just two lines, right? I've got two lines. I want to see if they cross, where do they cross? Or if they don't cross, or maybe there's one other option. So how do two lines in the same plane interact? Well, they could have two different lines here, and I could have one solution right here where they cross. I could have one solution. Another way, I could have two lines that don't ever cross because they are oh, that's really bad. How about that? No solutions because they are parallel lines. And the third way that two lines could interact is actually if the lines were both the same line. So I'm just going to kind of draw this no, I'll do this a little bit better here. Got two lines in here. Trying to make this really big to say there are an infinite number of solutions because they're the same line. Same line. Okay. Now, with that said, one of the most efficient ways we can get this done to see if they cross, and if they do cross, where do they cross, or are they parallel, or are they the same line? One of the best ways to do this is using algebra methods. We could add or subtract the equations. Add or subtract the equations. We could also substitute. Use substitution. Oh, you might have to multiply in here first if you're doing the add. Maybe multiply. Okay. So what I'm going to focus on this time, though, is substitution. I think this one's a really good method, and it provides a standard way we can look at it every time. All right. So I'm going to do an example that's two lines, a linear system. This first one says steps for using the substitution method. Solve one of the linear equations for one variable. So I've got two different lines up here. I've got x minus 3y equals -7. I've got negative 2x plus 4y equals 8. Well, I always also say here, make it easy on yourself. Make it easy on yourself. What do I mean by that? Well, what I'm trying to say is, if you don't have to deal with fractions, especially if you don't like fractions, don't. I'm looking at example number one, or the line one here, x minus 3y equals -7. I see right here, I can do one step and have one variable isolated. If I added 3y to both sides, I'd have x equals 3y minus 7. I've just solved one equation for one variable. And now I'm going to substitute that result into the other equation. Anywhere I see x in the other equation, I'm going to replace it with 3y minus 7. So -2 times 3y minus 7. Again, it's the whole thing. It's not just the 3y. That's why I put parentheses around it. Plus 4y equals 8. That's step 2. Substitute the result into the other equation. Step 3 says solve for the variable that remains. Well, the variable that remains here is y. How I'm going to do that? I'm going to start by distributing through. -6y plus 14 plus 4y equals 8. I'm going to gather my like terms. I've got negative 6y and positive 4y, so negative 2y. I'm going to subtract 14 from both sides, equals negative 6. And to solve for y, I divide both sides by negative 2, and y equals 3. Well, if I'm looking up here, at these graphs, we know that these two lines cross one time, and we're y equals negative 3. But we're missing something. We also need to know where it crosses in the x variable. So I've got y equals 3, and it says plug the result into the equation from step 1 to find the other variable. Oh, I've got one. X equals 3y minus 7, or x equals 3 times 3 minus 7. 3 times 3 is 9, minus 7 is 2. These lines cross when x is 2 and when y is 3. This is my solution. I'm pretty sure it is, and I can check this. If I go back up here and plug this, again, we said it's 2 comma 3 for this example. 2 minus 9 is negative 7, because that's 3 times 3. Or negative 4 plus 12 is 8. We're good to go. We checked our solutions. We see everything in there. We are good to go for this one. This is correct. We checked our solution. This is going to work very similarly to if we're doing the linear quadratic system. So what is a linear quadratic system? Well, basically the same kind of thing we've been talking about. Linear quadratic system, how a line and quadratic interact. How a line and a quadratic interact. And when I say a quadratic, one example could be a parabola. That's what I'm going to focus on in this. Could be a parabola. It could be a circle. It could be something that you haven't seen before, but still a quadratic. It could be a hyperbola. It could be an ellipse. But no matter what it is in terms of its shape, the math still works the same. Okay. How many ways can a line and a quadratic interact? Again, examples, I'm going to give parabolas. You could have circles, doesn't matter. I could have this parabola right here and this line right here. I could have two solutions. Interesting, right? It crosses here and here. Well, what if I took this parabola again and I made it just touch right there? I could also make it have one solution. And then the last one, I don't know if it's obvious or not, but the last one we could possibly have, I got the parabola again. And what if my line just does this? Does it touch anywhere? No, this would be no solutions. So these are the different solution types you could possibly have for linear quadratic systems. A little bit different than just straight linear systems. But again, we're going to do the same kind of thing. What are a couple different methods? Well, we could do graphing, or we could do algebra methods. Because we want accuracy, we're going to focus on algebra methods. And more specifically, we're going to focus once again on substitution, because it's basically the same thing. Now, you're saying, well, how are we going to do that? Because it's got some squared things. And yeah, we're going to have to solve by, I don't know, taking the square roots, maybe completing the square, maybe factoring, maybe quadratic formula. And I'll tell you how I'm going to go about this. My two favorite, factoring and quadratic formula. If I see real quick that it's something that factors, I'm like, oh, yep, multiplies to that, adds to that, factoring. I would highly suggest going with factoring. But like we talked about before, the quadratic formula works every single time. So if you're more comfortable with that, that's fine too. But I'm going to look first if I can factor, and then I'm probably going to go right to the quadratic formula. Also, if I've got an a value, an ax squared plus bx plus c equals 0, or ay squared plus by plus c equals 0, if I've got something in an a that's not 1, if it's like maybe 3x squared, I'm probably going to go right to quadratic formula. Let's go ahead and take a look at what this might look like here. All right, I've got two things going on here. I've got a linear quadratic system, x minus y equals 7, and x squared minus y equals 7. Solve the linear equation for either variable, make it easier on yourself. I'm going to highlight, I've got the line and the quadratic. You know the line versus the quadratic. The quadratic has a squared term. The line will not. I've got x minus y equals 7. I can see, all right, x minus y equals 7. Make it easy on yourself. Now you can think ahead also. This would be a good candidate to solve for y, because I wouldn't have to do a whole lot with this thing. But I'm going to solve for x because I think that's where a lot of you were probably thinking. So if I do, I'd add y to both sides. X equals y plus 7. Substitute to that result into the quadratic. So anywhere I see x, instead I'm going to put y plus 7. Y plus 7 squared minus y equals 7. This is where you have to be careful, because a lot of you right now are thinking, oh, that's just y squared minus 49. And it's not. Remember, when something's squared, it's itself times itself. In other words, it's y minus 7 times y minus 7. Now, we've got a couple different ways we can approach this because they are binomials. One of the ways you could do is FOIL if you wanted to, or you could use the distribution method, or you could use the box method, however you're comfortable with it. I'm going to remind you of distribution. I'm going to take y and multiply it by y minus 7. And then I'm going to take the minus 7 and multiply it by y minus 7. Y times y, I'm going to distribute again. Y squared minus 7y minus 7y plus 49. So I've just found that y minus 7 squared is actually y squared minus 14y plus 49. I still have, though, minus y equals 7. So this is all part of step 2. Step 3 says write the result of the form, write the result in the form of a general quadratic equation. In other words, you want like ax squared plus bx plus c equals 0, or you want a y squared plus by plus c equals 0. In other words, you want everything that's got a value on one side and a 0 on the other of the equal sign. Well, what I'm going to do here, I'm going to combine my like terms and also subtract 7. So this gives me y squared minus minus 15y. Oh no, I did adding. Oh no, Mr. Brayman, what are you doing here? Hopefully you guys saw what I did. Okay, let's go back. This is actually supposed to be y plus 7 times y plus 7. Okay, we're going to roll through it again. Y plus 7, y plus 7. I apologize. Same kind of thing though. Y times y plus 7 plus 7 times y plus 7. I apologize. Y squared plus 14y plus 49. Y squared plus 14y plus 49 minus y equals 7. That's my fault. I apologize. I apologize. Still the same thing. Y squared plus 13y plus 42 equals 0. So we've done step 3, right? We've written the form in general. We've written the result in the form of a general quadratic equation. Okay. From here, I need to solve. I'm going to either look, me personally, I'm going to look at factoring or quadratic formula. I see right away, I'm like, you know what? That's factoring. That's factoring. Because I know what multiplies to 42, but adds to 13. Y plus 7 and y plus 6 equals 0. Now what I'm going to do is find my y values. I've got 2. This crosses 2 times. This has 2 solutions. Those solutions are when y is -7, when y is -6. Well, just like in the linear example, they don't just cross, or they just intersect at a y value. We also got to find an x value. Fortunately for us, we've already found out that x is equal to y plus 7. So let's go here. When our y is -7, when our y is -7, I have x equals -7 plus 7, which is 0. So when x is 0, y is -7, my first coordinate point is 0, -7. That's one of my values. I have to also check when y is -6. X equals -6 plus 7, which is 1. So in other words, 1, -6. These are the two places that the line and quadratic interact. Okay, we just followed those steps and we're okay. Again, just forgive me for making that mistake and seeing -7 instead of +7. Okay. Again, this is what it looks like for 2. For 1, it's going to pretty well look the same way. We're going to do the exact same thing. In fact, what I would like you to do is to give this one a shot on your own. Use the same step we just went through, come back, check your work, and I'll go through it anyway. All right, hit pause, then come on back. All right, let me go ahead and talk you through this one. We're going to do the same steps here. Our same first step is solve the linear equation. Well, let's figure out what's the line. That's the bottom equation. Makes the top the quadratic. Solve the linear equation for either variable. 2x equals y. Well, this is, I don't want to say an easy choice, but since I don't want to deal with fractions, I'm going to solve for y. I'm going to say y equals -2x, and that's just it, because there's no other value. So anywhere I see y in the quadratic equation, I'm substituting in instead -2x. X squared plus -2x plus 1 equals 0. Again, this is going to be a one solution example if you're not sure, weren't sure. Well, plus, this is like distributing a 1 through, so x squared minus 2x plus 1 equals 0. The first thing I'm going to look for is, can I factor this? And this is already in my general quadratic form, so that's good. Can I factor? Is there something that multiplies to 1 but adds to -2? Oh, yeah, there is. There is. I'm going to do factoring on this one. I'm going to say this is x minus 1 times x minus 1, or x minus 1 squared. In other words, it's a double root. It's a double root. And where does that root happen? When x equals 1. We solved one of our factors when x is 1. Fantastic. Once again, it doesn't just cross at an x value. We also need a y value. Fortunately, we have an equation that says y equals -2x. So y equals -2 times 1, which is -2. In other words, this line in quadratic intersect when x is 1 and y is -2. A great way to check this would be go to Desmos, plug that in, make sure that they cross one time. You could do that one. You could also plug it back in, check both of them, it would work. And hopefully you're saying to yourself now, well, what does it look like when I have no solutions? And I'm here to tell you what that looks like. Example 3 is an example with no solutions. Once again, same first step. Let's figure out what the line is in the quadratic. Well, I've got an L there and a Q here because that's squared on top. We should plug that top one in and see what the shape is in Desmos. I got a line in the quadratic. Okay, 2y equals x plus 12. I'm going to make it easy on myself. I'm going to solve for x. I'm going to say this. I got 2y equals x plus 12. The nicest thing to do for me, subtract 12 from both sides. So x equals 2y minus 12. And anywhere I see x in the first equation, I'm instead going to put 2y minus 12. Now, I'm not going to do parentheses this time. I don't need to, because it's just x. It's not being multiplied by negative any other value. It's just 1x. So 2y minus 12 equals y squared minus 5. Well, now I got to get all the stuff onto one side. In other words, I'm going to subtract 2y and add 12 to both sides. And when I do that, these go to 0. And I have 0 equals y squared minus 2y plus 7. Now, 0 equals, or you could just write equals 0. That would work also. And so now we've gotten to that step 3 part. Got to that step 3 part. Now we need to see if we can, or how to solve. I'm looking, can I factor? No, because what multiplies to 7 and adds to -2? Nothing exists. So how are we going to solve this thing? I already told you there's no solutions, but how do we figure that out? Well, we're going to use the quadratic formula. And so what we're going to do is, like I always talk about first, do the discriminant first. So let's write everything down here. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now, hopefully for you eagle-eyed viewers at home, you've noticed something, or you remember back to when we did solving by the quadratic formula, and we figured out how to find out how many answers and of what type we have. And that is this discriminant right here. This b squared minus 4ac will tell us if we have any real solutions. Well, in this case, a is 1, b is -2, and c is 7. So let's go ahead and just do b squared minus 4ac. If this value comes out positive, we've got 2 real solutions. If it comes out to be 0, we have 1 real solution. And if it comes out negative, we have no real solutions. So let's go ahead. B squared, -2 squared is 4, minus 4 times 1 times 7. Again, I like to do b squared, then 4ac, and then subtract them. So I've got 4 minus 28 is -24. Because the discriminant is negative, we have no real solutions. In other words, this line and this quadratic will not touch. That's what we got for you today. That is the rundown on this one. You're going to want to get right into practice 1. Start trying these. Again, think ahead as you work through them. Look at both the line and the quadratic. Maybe minimize how much you got to do some squaring and some fraction kind of work. All right. Hope you guys have a great day. Take care. Talk to you later.